All right, welcome to the review for standard for solving systems of equations using the equal values method and graphing. We're going to start with the equal values method. So in Delta Math it's called substitution level 1, but we've learned it as the equal values method. It's just a special case of substitution. So first we want to look at our equations. We have y equals negative 8x plus 6 and y equals negative 6x. So those are our two equations. Because they are both equal to y, we can say that this expression is equal to that expression. Right? They're equal to the same thing, so they must be equal to each other. So let's go ahead and set them equal to each other. Now we have one equation and only one variable in it, so we can actually solve for that variable. So to solve for this variable, I want to get all of my terms with x combined and on one side of the equal sign, and all of the rest of the terms on the other side of the equal sign. In this case, I'm going to add 8x to both sides, and I'll get negative 6x plus 8x is positive 2x. This negative 8x plus 8x is going to cancel out. And then I'm just left with 6. Okay, so now I have all my x's on the left and all my constants on the right. It's totally fine if yours are switched. Doesn't matter. In this case, my x happened to end up on the left. Now, we have 2x here, but we only want one of them. So to isolate x, I'm going to divide by the coefficient on it, which in this case is 2. So I divide by 2, and since I did it to one side, I have to do the same thing to the other. And I get x is equal to 3. Awesome. But I'm not done, because a system of equations has an x part of the solution, and it also has a y component to the solution. So now I can use my x value to find the y value of the solution. And I do that by writing down one of my equations. I'm going to start with y equals negative 6x. It's a simpler equation, so I just picked it. It doesn't matter which equation you use. It could be either one. So now, instead of this x, I'm going to replace that with a set of parentheses and fill in the value that I found for x in my first part. So that is 3. So once again, the original equation was y equals negative 6x, right, up here. I solved for x, and now I'm taking this x value of positive 3, and I'm plugging it in where there was an x in this first equation. So when I follow order of operations, negative 6 times positive 3 is negative 18. So technically, I could say that I'm done here and just say, okay, my x is 3 and my y is negative 18. But I want to be doubly sure. I want to check. So to check, I'm going to use my other equation, the y equals negative 8x plus 6, and I'm going to replace the x's and y's with these x's and y's. So I have y equals negative 8x plus 6, but I'm going to replace the x and the y with negative 18 and 3 respectively. So again, this was our y value and this was our x value. Then I follow order of operations until I see if I have a true statement or not. So negative 18 is equal to negative 8 times 3 is negative 24. Plus 6 comes along for the ride. It's multiplication before addition. Then I combine like terms and I get negative 18 equals negative 18. Okay, so this checks out. So this step was just me checking my answers. My answers I already had. X was 3, y was negative 18. But when I plugged it into my other equation, it allowed me to check and confirm that the numbers I got were correct. To enter your answer into Delta Math, you have to enter it as an ordered pair. Just like in the alphabet, X comes first. So our X was positive 3, and our Y is negative 18. Then you'll hit submit. It'll ask, are you sure? You say yes. And there you go. Remember, you need to be writing out all of your work and showing all of your steps, even though the test you're going to take is in Delta Math. All right, let's look at how to solve a system by graphing. So in your level 1 solving systems graphically, both equations are already in slope-intercept form. So that actually makes it a little bit easier for you because we can go straight to graphing. Before you do that though, I recommend you just jot down y equals mx plus b. And remember that m is your slope and b is your y-intercept. Okay. To graph these, I recommend you follow this process each time. Start with your y-intercept. So in our first equation, that's negative 1. So I'm going to click right here at negative 1. Then it says our slope is negative 1/5. So since it's negative, that tells me I'm going down. And since the numerator is 1, that means I'm going down 1 and then over by the denominator, which is 5. So I'll go down 1 and then over 1, 2, 3, 4, 5 and click. So that puts my second point there. Be really careful that you're precise with your graphing. For my second line, I'm going to follow the same process. Start with the y-intercept, negative 6. So that's down here. Boink. And then it says the slope is positive 4/5. So I need to go up by 4, 1, 2, 3, 4, and to the right by 5, 1, 2, 3, 4, 5. Excellent. There's my second point. In this case, my second point happens to also be where the lines intersect. That won't necessarily happen, but either way, you'll be fine because the solution from these graphs is at the point of intersection. So this set of equations, this system of equations, when graphed, intersects at this point 5, negative 2. So for my solution, I need to type in that as the coordinate. So always in parentheses for coordinates, and then 5, negative 2, right? Our x value is 5, and our y value is negative 2. Submitting our answers. Yes, I'm sure. It always makes me second guess myself, right? But yeah, no, I've got it, Delta Math. And there we are. Cool. Last but not least, we have another system of equations that we're going to solve graphically, but this time only the first equation is in slope-intercept form. That means we're going to put the second equation into slope-intercept form before we graph it. There are other ways to graph it straight from standard form, but we haven't really worked with those yet, so we're going to put it in slope-intercept form because that's what we're familiar with right now. So I'm going to graph this first equation first. Once again, I'm going to start at my y-intercept, that's 5. And then because this just says x, there's an invisible 1 there. Anytime we see an x, we know that it's 1x, but we don't always write the 1. But it's there, which means the slope is 1. So I go up 1 and to the right 1. And there's my first graph. Next, we have this 3x plus y equals negative 7. That we need to isolate y. So I'm going to say 3x plus y is equal to negative 7. this one is going to be pretty straightforward to isolate y because check this out. There's already one y positive, and all we need to do is get it by itself. To do that, this is what's in the way of it being by itself. I'm going to subtract that onto the other side. Minus 3x, did it to one side, have to do it to the other. So these will cancel out. I'm left with this y. And to write it in slope-intercept form, write this first, right? So minus 3x, so negative 3x, minus 7. So now we can see from this equation that the y-intercept is negative 7. So I'm just going to plot that now. And then the slope is negative 3. So I have to go down 3, 1, 2, 3, and over 1. And there's my second line. So this line that I just plotted is the graph of 3x plus y equals negative 7. Okay, the solution is at the point of intersection. That's right here. So, looking carefully, I can see that the x value is negative 3 and the y value is 2. Remember, x then y inside parentheses so that it's a coordinate, so that it's an ordered pair. We submit our answer, say yes, awesome. Now, I'm going to try and find a slightly more complicated problem to move from standard form to slope-intercept form, just so you can see how that works. Ah, great. So, one more time, nothing like a little math for your evening. All right, so first things first, our first equation is already in slope-intercept form. I'm going to plot that. My y-intercept is positive 4. So here is positive 4. And then the slope says negative 1/2. So I'm going to go down 1 and to the right 2. Down 1 to the right 2. So that's my first line from this equation. It's already in slope-intercept form, so it's nice and easy to graph. Next, I need to take this 5x minus 4y equals 12 and isolate y. So 5x minus 4y equals 12. And the first step is going to be basically the same as what we did in the previous equation. I'm going to get my y term by itself by moving the x over, in this case using subtraction. If this were a negative 5, I would just add 5x to both sides. So 5x minus 5x is nothing. So on the left here, I'm left with just negative 4y. Notice, this was minus 4y, so this stays as a negative 4y. This negative sign doesn't disappear. It's still there. Then, I'm going to write this in slope-intercept form. So I'm going to say negative 5x plus 12, because this was a positive 12, so I'm adding it. Now, unlike before, I still have a coefficient that's not 1 on that y, which no bueno. We need one y by itself. So to isolate this y, I need to divide by its coefficient, which in this case is negative 4. I'm going to divide every term by negative 4. So negative 4 divided by negative 4 is 1. So that gives me my 1y. Then negative 5 divided by negative 4. Well, a negative divided by a negative is a positive. And here is where I really recommend you leave this as a fraction. It will help you see your slope so much better. You could totally make this a decimal, but that's not actually going to make it easier for you to graph. There's still an x here. That x is very important. And then here, positive 12 divided by negative 4 is negative 3. So it's going to be minus 3. So here we have it, our slope-intercept equation. It tells us our y-intercept is negative 3, so I'm going to click there first. And then the slope is 5/4, so I'm going to go up 5, 1, 2, 3, 4, 5, and to the right 4, 1, 2, 3, 4. So there we go. Once again, our solution is at this point of intersection. We write it as an ordered pair inside parentheses. The x-coordinate of that point of intersection is a 4, and the y-coordinate is 2. All right. I hope that was helpful. Happy studying, and have fun with your upcoming standard.